Hello, let us start our discussion about the IP videos. As we have already seen about the IP audio in the previous session, if you do recall, we have discussed IP audio in a detail. So in today's session, we are going to cover IP video in a details, and I am the presenter, Mrs. Suvarna Kadam. So let us start our discussion regarding IP video. Now, what do you mean by IP video? Whenever you are converting your video, which is say in the analog format, in the compatible or which is compatible with the internet protocol, that video will be called as the internet protocol video. Now, what that particular IP video communication includes? So, if you see here, the first thing which you are doing with your normal video, I can say normal video is nothing but the analog video. You are digitizing the video. We know that the same processes will be there. You're going to sample, you're going to quantize, you're going to encode that thing. Next is the video coding. You're coding that video, then addressing will be done, transferring, receiving, decoding. And now if you see here, the first three steps are related with the transmitter side, or you can say this first three steps are with the generator side. ठीक है, and transferring, actually you are transferring that data, and at the receiver side you are going to receive that data, you're going to decode that data, and you are going to convert IP video to the original form of the video. So these are the 7 steps involved in the IP video communication. Now let us discuss each step one by one. Now as we know that camera will take all the non-electrical kind of visual information or the light information, which will convert it into the say electrical quantity, which we call as a composite video signal or a video signal. That video signal will be given to digitize and compression section, where the digitization will take place, compression will take place. Then the time stamping process will actually stamp each and every packet at the time which it is generated, at which it is generated. Because whenever you're putting all that things on the internet, you don't know, or on the network, you don't know which route that particular packet is going to follow. So timestamp process will help my receiver to understand कि वो packet at what time it is generated. Then IP address allocation, each packet, with each packet my address will be attached, so that is done in the IP address allocation. This is a packet switching network. Actually it is connected, or it is having several routers in it. Okay, and each router will have a routing table. So if my packet comes from a particular interface and it want to go to the, like, say another interface, which route I should give to that particular packet. So this is the packet switching network, and this is the scenario at the transmitter side. Now what happens at the receiver side? Now this packet will be received with the IP receiver section. Then now I don't have any I can say guarantee that whatever sequence which I have transmitted, the same, with the same sequence I'll receive the packets. That's why I have a time sequence process. It will take help of that timestamp process, and it will sequence all the packets in the order as they have generated. Then it is given to the video converter section. Now my video converter section will convert my signal into the visual format, which is given to the picture tube, and then again I am able to see whatever picture in the original format. So this complete gives you idea about the IP video system. Now to understand the IP video, I must understand some of the basic concepts or some of the basic definitions related with my video. So first is the resolution. What do you mean by the resolution? What you are doing in when you are converting your analog video into the digital audio, you are sampling, quantizing, encoding, and then all that things will be in the form of pixels, right? So it is the number of image element that we call pixels per unit area is the resolution. So the image display with a finer grid contains more pixels, so reproducing more details of the images, and therefore it is said to be higher resolution image, and vice versa. So higher image resolution images will have a greater or higher quality, and a lower resolution images will have a lower quality. So every, like, higher images are higher resolutions are having their own advantages, and lower resolution images are having their own advantages. So here if you see the frame rate, so it is the number of images that are displayed to the movie observer over the period of time. It is given as a frames per second, and short form is FPS. So 1 2 3 in 1 second, if I am transmitting, or if I am just scanning a 3 frames, it will be called as a 3 FPS. Then I have just increased here 1 2 3 4 5 5 frames per second. Then I have gone to the 10 frames per second. So what happens when you are increasing the number of frames? With the lesser number of frames, less bandwidth will be required. ठीक है. But here less bandwidth will be required, your resolution will be, or I can say your clarity will be less because you're transmitting your data with a less resolution. Then as your number of frames increase, your bandwidth requirement will increase. Here whatever I have transmitted at the end, or whatever you can see at the end, 10 frames per second will have a more bandwidth. ठीक है. ज़्यादा bandwidth है, लेकिन उसका another advantage is a less flicker because you're having more number of frames. Here flicker, as the less number of frames, more flicker, less bandwidth. Flicker increases, bandwidth increases. सॉरी, यहाँ पे फ्लिकर डिक्रीज हो रहा है, बैंडविड्थ इंक्रीज हो रहा है. यहाँ पे आपका बहुत कम फ्लिकर है लेकिन ज़्यादा बैंडविड्थ. सो इट इज़ हैविंग इट्स ओन एडवांटेजेस, राइट. नाउ दिस इज नथिंग बट द different video system which uses a different number of frames. So American video system uses 30 frames per second. American TV system uses a 60 fields per second, or frames per second, you can say in that way also, because at 30 frames are divided. Here we are using in the television system interlace scanning, so 30 frames are divided into odd field, even field. So 30 into 2, it becomes a 60 fields per second. Films uses 24. Motion picture में आपका 24 frames per second है. European TV system, that's our system, that is 50 frames per second, and European video system is 25 frames per second. So these are nothing but the different frame rates for different systems. ठीक है. Next one is nothing but the aspect ratio. I think we have already discussed about the aspect ratio. Width to height ratio is called as the aspect ratio. So it is the ratio of number of pixels on the screen as compared to their width and height. So it is decided, or it decides the frame shape of an image. So if you see 16:9, you are having a more wider screen, and you are having the 16:9 aspect ratio in high definition television. Letterbox. Now this is the method of displaying widescreen images on the standard television receiver, where the widescreen aspect ratio is much larger than the standard television or PC monitor having aspect ratio as 4:3. So it causes the image display, or image appears within the border at the top and the bottom of the image, producing a horizontal boxes known as the letterbox. Suppose your system gives you the 16:9 aspect ratio, you are going to reproduce it on the standard 4:3 television system. So you are putting that letterbox at the top and at the bottom of that particular image, of that particular video or image, you can say. Now we are going to discuss about the analog video interfaces which we are using here. So coaxial video cable, you are using this for PAL, NTSC, CCAM. So if you have seen, these cables are used to connect your television antenna to your receiver system. ठीक है. Composite video signal. Now this composite video signal, as we know that, like, you might have seen this kind of the cables at your home. So this white and red, these two cables are used for the audio. So red cable is used for write audio. So sorry. So you can see here, if you do recall whatever cables you have seen in your home, so this red cable is for write audio, and I can say, this, if you see, this white cable is used for the left audio, this is for the right audio, and this yellow cable is used for the video. ठीक है. So set top box से आपके ये जो आते हैं, जिसको कहते हैं composite video. Next one is the separate video. Now you can see here the separate video signals are there. So you know that RGB, this thing, three things are given over here. The luminance is provided separately, something like that. Component video, in the component, अगर separate video में देखेंगे तो RGB अलग अलग दिया है और आपका luminance भी अलग दिया है यहाँ पे. ठीक है. अगर component video में देखेंगे U, V and Y, so this will be called as the component, because U, V are, these are nothing but the, so you know that U is nothing but the 0.493 B minus Y, and this V is nothing but the 0.877 R minus Y. ठीक है. So ये VGA cable is a video graphics array video. So here this cable you might have seen. So these are some analog video interfaces. Next one is the digital video interface. So this kind of cable is again there, where you are connecting your digital video. Okay. HDMI is a high definition media interface. So this kind of cable is called as the high definition media interface. So some of the analog interfaces, some of the digital interfaces we have seen. Now digital video interfaces, you are having a source and a sink. So you're using different connectors at source side, at a sink sides. So UDI stands for Unified Display Interface. ठीक है. Next one is nothing but the when it goes to the digitization format for video, we are having 5 digitization formats, and these formats are called as the CCIR 601 digitization formats. So you can see here 4:2:2, 4:2:0. One is used for recording purpose. This will be used for recording. This will be used for broadcasting purpose. This is for the storage SIF. Source intermediate format. This is a common intermediate format. This is a quarter common intermediate format. So we have already or we can discuss this particular CCIR 601 digitization format separately, but right now you understand this is 4:2:2. When I say I'm sampling my luminance with the 4 samples, okay, so if I'm using 4 samples for the luminance, so on one line I'm using 4 for luminance, 2 I'm using for CR and CB. I rather use a different color for this one, so I'm going for, say, this is my, say, CR. So 2 samples I have used for CR, and again I'm going to use a 2 samples for CB. So I have a red color different signal, I have a blue color different signal. So I'm going to use 2 samples for CR, 2 samples for CB. So आपने 4 luminance के लिए use करे हैं. So 4 samples is for Y, 2 sample is for CR, and this is for CB on the one line. ठीक है? This means that 4:2. So 2 both for CR and CB. What does 2 stands for here? On the adjacent line, if you're going for an adjacent line, how many samples will be there for the chrominance signal? अगर आप next पे जाएंगे, ये 4 sample आपके luminance के हो गए, तो on the next you are using again the 2 CR and CB. ठीक है. अगर आप next line पे जा रहे हैं तो you are using 2 samples of CR and CB. अगर आप यहाँ पे भी 2 samples, ठीक है. So if you see here, this kind of approach will be there in this particular thing. So you are having this 2 samples. Okay. So here 4:2:0. What happened in the 4:2:0? You are using 4 samples of the luminance on one line, but on the next line you are not using any chrominance samples. ठीक है, आपके ये CRC भी जाएंगे उसी लाइन पे, लेकिन नेक्स्ट लाइन पे नो chrominance. ठीक है, सिर्फ आपका luminance जाएगा. So if you are going to talk about the luminance, यहाँ पे ल्यूमिनेंस है, यहाँ पे दोनों क्रोमिनेंस आपने भेज दिए हैं, लेकिन नेक्स्ट लाइन पे ओनली ल्यूमिनेंस विल बी देयर, नो क्रोमिनेंस विल बी देयर. ठीक है. सो दिस इज द मीनिंग ऑफ दिस वन. सो वन सेपरेट session will do on this particular digitization format. So these are the digitization formats. So if my chrominance, so if you see the human eye resolution, human eye characteristics, my eyes are more sensitive to the luminance rather than chrominance. So why to waste my number of or more number of samples on the chrominance if my eyes are not going to receive with that sensitivity? So in the 4 samples of luminance, I have used only 2 samples of the chrominances. That is what we call as a chroma subsampling. You have not used the exactly same samples for luminance and the chrominance. If you're transmitting luminance with the 4 samples, you're going with the 2 samples of the chrominance. That is what we call as a chroma subsampling. So in this way, you're going to reduce the bandwidth, and in this way, you are going to get the, you can say, the reduction in the bit rate. See, you're going to use 4 samples of luminance, 2 samples of the chrominance. Here you can see 4 samples of luminance, 2 samples of the chrominance, but not on each line. On the alternate lines, you'll get that one. Okay? So in this way, these 4 formats will give you the compression of your video signal as you need it, or with the rate which you need it. So you can say 4:2:0, 4:1:1, storage intermediate format, 4:1:1, common intermediate format, 4:1:1, quarter common intermediate format. So here the bit rate will be reduced, and in short we can say, or we can conclude that our bandwidth will reduced. What is the video digitization? So it is the process of conversion of a video component signal or a composite digital form through the use of analog to digital converter. So the output of the A to D converter is series of the digital pulses which represents the level of the optical image. So digital video may be created from analog video with the help of following processes: video capturing, quantization, and film to video conversion. So what is video capturing? It is the process of receiving and storing video images. It refers to the capture of and conversion of video images to the digital form. Quantization, it is the process of representing sample signals with a range of defined digital values. Quantization noise or quantization error is present in the process of quantization. Now, film to video conversion, it is a process of scanning film, that is movie images, and converting it into the sequence of video images in the IP communication or IP video communication. So frame rate is adapted through pull down process because the frame rate of film is different than the video. So you can see your videos, see your picture or motion picture is having 24 frames per second, and your television system is having say 60 fields per second in American system. So this you have just derived two frames from one frame, you have derived 3 frames from one frame. So this process is called as a pull down process in the film to video conversion. Video compression, as we know that, see, this is nothing but the your one scene, and these are the 3 pictures in the one frame. So instead of encoding each and every frame, as we know that in the one scene, if I check two adjacent frames are having a higher correlation or maximum similarity, so encode only first frame. The second frame you are not supposed to encode completely, just encode the difference between these two frames. As these two frames correlate more, the difference will be less, and whatever bits I need to encode that particular error will be less. And in short, what we can conclude from this, whatever bandwidth will require to transmit this video information will be less. So digitize all lines and pixels here. This is what we called as the keyframe. Okay. Then the next, you are compare digital images, calculating the difference between it. पहले आपने इसको digitize किया, ये digitize है, दोनों को subtract किया. So आपने सिर्फ उसका you have taken only the difference. As two adjacent frames correlate more, difference less, the low bit rate will be there. The low bits will be needed to encode that data. ठीक है. Again the next, the same scene का third frame आप same you digitize that, you take the previous frame, compare digital images, calculate the difference between that, changes to the pictures will only be encoded with the low bit rate, and hence the compression will be achieved. ठीक है. So this is what we call as the principle of the compression. Typical live streaming, it shows that instead of, they don't need to download all the data, don't wait for downloading or storing all the complete information on your server. While streaming you can watch that particular content. So this is a typical live streaming. You are having a video camera with a live production, this will be the stream, this will be the streaming server, that stream will be given to the internet and you can watch it live there. So this is a typical live streaming. Typical on demand streaming, that you are just requesting the content, so you are having the request clip, that request clip goes to the server, then that will be uploaded and that will only be given to your system. So this is on demand streaming. Download and play option, so unless and until the complete file gets stored on your server, you are not able to see it. That is what we called as the download. Okay. So here streaming without saving it to the hard disk, you can see the content. So what is the requirement of you can say this particular streaming? So you need a streaming servers over there, so web server and a streaming server. So we'll compare these two things, the traditional web server and the advanced streaming server. So advantages of web server is part of existing infrastructure, no additional expertise of training for IT staff. Here in the streaming server, optimized media delivery, dynamic stream control is there, interactive media control will be there, multicast support will be there, improved server hardware utilization, then supports a live webcasting. ठीक है. डिसएडवांटेजेस, नन ऑफ द स्ट्रीमिंग सर्वर एडवांटेजेस, ये जो भी 5 एडवांटेजेस है यहाँ पे नहीं है, 5 to 6 एडवांटेजेस, ओनली सपोर्ट्स प्रोग्रेसिव डाउनलोड. ठीक है. Here in the streaming server you need a additional equipment. So this is the in short comparison of traditional web server and the streaming server. Now digital video quality, now it is the ability of a video transfer system to recreate the key characteristics of signal transmitted in IP video communication. So here digital video and IP video transmission system impairment includes following things. One is a tiling, error block, jerkiness, artifact, that is edge business will be there. Object retention, same object will be there in the next frame. Aliasing effects because of your say undersampling kind of thing. So you can see here a typical webcast and on-demand traffic. So you are having a source with a live event, you are having a source with a pre-recorded contents, direct streaming, live streaming is possible. With a file transfer protocol, you can simulate that video and simulated live can be shown. Then on demand, it will be the interactive. Okay. Now IP video distortions, as we have seen in the audio, there will be distortions in the IP video also. Your camera will convert it into the say video signal, then it is converted into digital, then it is given to the video codec section, whereas the coding for each and every video will be given with the reference of codebook. Then it is given to the channel coding section, which will take care of error detect, error correct, or flow control, that is data rate control. Then all that things will be put on what, on your internet, or you can say packet switching network. So you are having packet corruption, you are having a packet lost, you are having delay in the packet, like that. So what kind of distortions you may observe in your received video? One is the retain object, previous frame का यहाँ पे आ जाता है, tiling, that is tiling effect, and then error block. So this kind of distortions may observe in your video. So this digital video error blocks, जैसे हमने पहले देखा, इनिशियल एरर यहाँ का जो ऑब्जेक्ट है यहाँ पे रिटेन हो गया, ये एरर यहाँ पे रिटेंशन हो गया है, ठीक है. एंड दिस इज द मॉस्किटो नॉइज इफेक्ट, दिस इज बिकॉज ऑफ अलाइजिंग इफेक्ट, यू मे सी दिस मॉस्किटो नॉइज इफेक्ट. अलाइजिंग, if you are not satisfying the Nyquist criteria while sampling the thing, so your sampling frequency must be greater than twice of fm. Okay. So this again they have shown you some of the examples. These are the image objects in one frame, this is the second frame, third frame, fourth. These are the actual how you should see this 4 frames. But in the object retention it may happen that frame 1 का जो object है वो retain यहाँ पे हो रहा है, यहाँ पे हो रहा है, यहाँ पे एक object और retain हो रहा है. So this is the example of a object retention. Streaming control protocols. Now whenever we are talking about the live streaming, there are two protocols which are responsible for this particular streaming. So we'll talk about the streaming control protocols in this particular slide. So these protocols are command, processing and procedures that are used for delivering and controlling the real-time delivery of audio or video data in IP video communication. So these protocols control a setup process. उनका काम क्या होता है? Just set up the communication, playing process, pausing process, recording process, tear down process. Tear down, just end the communication process. So these protocols are RTSP, that is real time streaming protocol, DSMCC, that is digital storage media command and control protocol. So whenever it comes to the live streaming, you need to talk about only two protocols. One is the RTSP, DSM and CC. What is this RTSP protocol? This is a real-time streaming protocol. So RTSP is an internet protocol which is used for continuous streaming audio sessions. So RTSP provides a control in bidirectional communication like playing process, stopping process, media position control, that is fast forward and reverse. DSMCC, this is the digital storage media, that is command and control. CC stands for command and control. So DSMCC is the MPEG extension that allows for the control of MPEG streaming. How that streaming takes place, that control will be taken care of this digital storage media command and control. DSMCC provides a VCR technology type features. So these are the two protocols. Now you might have already gone through MPEG codec timeline standards, when in the 1920 there was one group which is called as like voice codec group. There are two standards for compression, ITU standards and you can say ISO standards. So in the 1990, this ITU standards started with H.261, which is nothing but the base of your compression. Whatever versions you find with the MPEG 1, MPEG 2, that are derived by ISO, and whatever you will find with the H dot is for video, T dot is for data, G dot is for audio. ठीक है, वो जो H dot, T dot, G dot से start होते हैं, that are derived by your that ITU standards, and ISO standards are MPEG 1, MPEG 2. Whatever starts with the MPEG is ISO standards. So this is the timeline standards for MPEG codec. Now standard applications, MPEG 2, MPEG 4. Okay? MPEG 2 and MPEG 4, these are the joint ventures, you can say, by both the committees, that is ISO and ITU. So standard definition 3.8 megabits per second in MPEG 2. MPEG 4 में आपका 1.8 megabits per second. So you need a lesser bandwidth in the MPEG 4. High definition में 19 megabits per second in the MPEG 2, and in the MPEG 4 6.8 megabits per second. So you can compare how much compression you can get with the MPEG 4. Video rendering. So it is the process of converting media into a form which can be viewed by human. So video rendering includes a video compositor, spatial scalability, temporal scalability, loss concealment. So we'll see one by one. What is the video compositor? It is a device which takes two or more video inputs or graphics images and combine them into one video. Like a news channel, you will have text, you will have some background, you will have some news readers or news givers. So combining all that videos in one frame is the function of video compositor. Spatial scalability. So it is the ability of media file or picture image to reduce or vary the number of image components representing over a given spatial area without significantly changing the quality or resolution of the image. So thus with the use of progressive adding of image information, spatial scalability can be used to provide image in a different formats like mobile video format, standard definition TV format, or a high definition TV format. Temporal scalability. So it is the ability of streaming media program or moving picture file to reduce the data elements representing the media file for a particular time period known for a temporal segments without affecting quality of it. Now, loss concealment. So, it is a process which attempts to alter a signal in a way that it reduces the effect of error or packet loss. So, for example, the insertion of previous frame in a video sequence that had a frame lost. Okay, so this is reduces the effect of packet loss on the display screen. So this is all about the IP video. We'll stop here. In the next session we'll talk about the internet protocol television. So thank you.